minus a. Now here a is our a, in general a. So what will be f of s minus a here? Fs is our omega divided by a square plus omega square. Then what is f of s minus a? So in that fs, you put s is equal to s minus a. It will be what?
Omega by s minus a square plus omega square.
This one? Are you getting?
Yes, sir.
Others, देखो how I have applied fast shifting theorem. Are you getting or not?
Yes.
Similarly, cos के लिए भी कर पाओगे ना? If Laplace transform of e to the power at cos omega t. So in that case, ft will be cos omega t. Then fs will be s by a square plus omega square. Then what will be Laplace transform of e to the power st cos omega t by s shifting? Tell me.
S upon s minus a whole square plus omega square.
No.
S minus a whole divided by S minus a whole square plus omega square.
Yes. In the numerator also it will be s minus a, na? We are putting s is equal to
Yes,
s
sir.
minus a everywhere. So for cos omega t, Laplace transform is s by a square plus omega square. Now replace s by s minus a. It will be s minus a divided by s minus a whole square plus omega square. So similarly, you can find Laplace transform of e to the power at sine omega t is equal to s minus a divided by s minus a whole square plus omega square. This. Now,
Sir, cos omega t
ah,
लिखना अपना.
huh?
Sir, cos.
Sir,
Sorry,
cos
cos,
omega.
cos, cos. My mistake. It is cos. ठीक है? Now, another type I am asking you. Tell me, what is the Laplace transform of t square e to the power say minus 3t? Tell me. देखो, there are no tabulated formula for it, right? T square e to the power minus 3t. Have there any function like this? No. So you have to think what I have additionally. So additionally, you have S shifting theorem, S shifting property. Now, still now you have the knowledge of S shifting theorem. So can you apply S shifting theorem here? Is it, first of all, you have to think, is it of the form e to the power at into ft?
Yes, sir.
So here ft is what?
T square
T
T
square
square, and the value of a
minus 3.
minus 3.
minus 3. Then it is of the form Laplace transform of e to the power at into ft. Now ft, that is t square. Then what is fs? Fs means Laplace transform of ft, small ft, means Laplace transform of t square. What it will be? It is a tabulated one.
So 2 by S
2
minus.
factorial upon s by 3.
2 factorial by s cube, or simply 2 by s cube I can write this. Now Therefore, Laplace transform of e to the power minus 3t t square, it will be what? F of s minus a, right? Now s minus a means what? S minus a means s plus 3, s minus of minus 3, right? So it will be actually f of s plus 3 by s shifting property. Okay, do you get it why it is s plus 3? Because a is minus, na? The form is f of s minus a. Now here a is minus 3, so s minus of minus 3, f of s plus 3. Okay, now we know capital Fs, that is 2 by s cube. Then what is f of s plus 3? This. Any doubt? Tell me, is it clear or not?
Yes, sir.
Yes, sir.
Okay. So this type only you can write. Now means a typical type of problem can be formed by using Laplace inverse. Okay, so I am asking Laplace inverse of two s plus 1 divided by s plus 1 whole square plus 4. How to find Laplace inverse? Look, only tabulated forms are this. Laplace inverse मतलब f of s वाला फॉर्म टेबल में ये सब है. You can ignore these two. 11, 12. How to adjust it? Here actually we have to use Laplace inverse form of S shifting theorem. Okay, Laplace inverse form of S shifting theorem. So what is the Laplace inverse form of S shifting theorem? Laplace inverse of f of s minus a, it is equals to e to the power atft. Fine, this form. Now tell me how to use it. Look, denominator, it is a common form, means that is matching with some tabulated formula s plus 1 whole square plus 4 means uh, it is of the form f of s plus 1, right? Means function of s plus 1, this type. ये a square plus omega square वाला फॉर्म है तो either cos आएगा और sin आएगा. Now, since in the denominator it is in the form of s plus 1 whole square, so what I am doing, I am arranging the means I am expressing the numerator also in the form of s plus 1. Okay, how to express it in the form of s plus 1 numerator. Can I write this? Can I write this or not? Or not?
Yes, sir.
Look, I have to express it in the form of f of s minus a. Now, the first form, it is not exactly in the form of f of s minus a, right? Because it is s plus 1 whole square, but here also it should be in the form of s plus 1, but it is not exactly in the form of s plus 1. So, to express it in the form of s plus 1, I have to uh, do this calculation, right? I have to represent it in that way. Now you can see it is a function of s plus 1, right? Capital F of s plus 1. Can I write this?
Yes, sir.
So it is capital F of s plus 1. Now देखो अभी क्या चाहिए? Means by the s shifting property, Laplace inverse of f of s minus a is equal to this. ये होता है. So e to the power at. Now if I know this a, I can write that e to the power at. Okay. Then if I know capital Fs, then taking its Laplace inverse, I can find ft. So I need a and I need capital Fs. These two things are needed to find this. Now tell me, sorry, it is not exactly f of s plus 1, it is Laplace inverse of f of s plus 1. Right? And after Laplace inverse, it will be a function of t. Now, here f of s plus 1 is 2 into s plus 1 plus or minus 1 s plus 1 whole square plus 4 square, sorry, 4 only. This one, f is plus 1. Yes. So what is a? Can you tell me? You compare with the form f of s minus a.
Minus 1.
A minus 1, correct. Because the form is f of s minus a. So a will be minus 1. Now f of from f of s plus 1, say it is equation 1, equation number 1. Now from equation number 1, can you write f of s?
Sir,
Yes.
sir, can you explain where that f of s plus 1 came? That part.
Huh?
Sir, where that f of s plus 1, can you explain that Laplace inverse of f of s plus 1?
Look, this function, how I have written this function, is it clear to you?
Yes, sir. Yes,
From the
sir.
previous line?
Yes, sir.
Okay. Now, don't you think that it is a function of s plus 1? Because the variables are in the form s plus 1. If I write 2x minus 1 divided by x square plus 4, I can write it is a function of x, na?
Yes, sir.
So similarly, it is a function of s plus 1. Can I write this?
Yes, sir. Yes, sir. Yes.
It is a function of s, but actually to apply that s shifting theorem, I have to express it in the form of s plus a. That is why I have written f of s plus 1. Okay, to apply the s shifting property.
Yes, sir.
देखो क्लियर हुआ है कि नहीं बोलो?
Yes, sir. Yes.
Okay, so we are assuming that this is f of s plus 1. Now f of s plus 1 is equal to this. So if you compare with the form of f of s minus a, then a will be minus 1. And now I need what? Small ft. So if I know a and if I know small ft, then we are done. Means I can write immediately Laplace inverse of that. It is what? It is e to the power at into ft. Now a is minus 1. So e to the power minus t into ft. अब ये एफ टी क्या है? एफ टी है लैप्लास इनवर्स ऑफ एफ एस. तो एफ एस भी चाहिए ना. तो एफ एस क्या होगा बोलो? फ्रॉम द इक्वेशन नंबर 1, एफ ऑफ एस प्लस 1 इज इक्वल टू दिस. देन एफ ऑफ एस you put
2s minus 1 whole divided by s square plus 4.
yes. In the place of s plus 1, you put s. That will be fs. In this place, s plus 1, everywhere you put s. You will get fs, right? Any doubt? बोलो कुछ डाउट है? देखो nobody replying. अगर कहीं पे कुछ डाउट है तो पूछो.
मुझे डाउट नहीं, थोड़ा कंफ्यूजिंग है.
कॉन्फ्यूजिंग क्या है? वेयर लुक, अगर एफ एक्स दिया है से एक्स स्क्वायर प्लस 1, तो क्या मैं एफ एक्स से एफ ऑफ एक्स प्लस 1 नहीं लिख सकता?
यस सर.
एक्स प्लस 1 होल स्क्वायर प्लस 1.
प्लस 1.
तो मान लो कि अभी ये नहीं दिया है, अब एफ ऑफ एक्स प्लस 1 दिया है, तो क्या मैं यहाँ से एफ एक्स नहीं लिख सकता? एक्स प्लस 1 की जगह पे एक्स
यस.
पुट.
यस सर.
सेम थिंग, मींस वाइस वर्सा केस ना.
यस सर.
From fs to f of s plus 1, it is trivial type, and from f of s plus 1 to fs, it is also trivial type, but it is looking some means different type, because normally x को x plus 1 लिखते हैं. तो x plus 1 को x लिखने से भी क्या दिक्कत है? एक्चुअली ये चीज करना पड़ेगा. f of s minus a से fs, ये करना पड़ेगा ही पड़ेगा whenever you are applying s shifting theorem to find Laplace inverse. Now we know fx, then it is very easy to find ft. ft, that is Laplace inverse of fs. तो Laplace inverse of 2s minus 1 divided by a square plus 4. What is it? Can you tell me? From this line, it may be unclear to you that which formula it needs. But if I write this, देखो इसको लिख सकते हैं ना, Laplace inverse of 2s by a square plus 4 minus 1 by a square plus 4. Can I write this? So Laplace inverse of it will be 2s by a square plus 4 minus Laplace inverse of 1 by a square plus 4. That is due to linearity property of Laplace inverse. Like Laplace transform जैसे मैंने बताया था ना, Laplace transform follows the linearity property. This one. Similarly, Laplace inverse also follows the linearity property. Laplace inverse of a into capital Fs plus b into capital Gs. It will be a into Laplace inverse of capital Fs plus b into L inverse of capital Gs. Okay. In place of L, you write L inverse, and in place of FTGT, you write capital Fs, capital Gs. It follows the same rule. So by that rule, I can write this. ये trivial मतलब naturally algebra में ये सब होता है ना, distribution, distributive property, you can say. These are not exceptional. These are usual things. Is it clear?
Yes, sir.
Yes, sir.
Now, what is Laplace inverse of 2s by a square plus 4?
Cos omega t.
2 cos 2t.
2
Cos 2t.
cos 2t. Correct. Any doubt? Minus it is what? Laplace inverse of 1 by a square plus 4. If it is Laplace inverse of 2 by a square plus 2 square, then it is what? Laplace inverse of 2 by a square plus 2 square.
Sin 2t.
Sin 2t, but that 2 is not there, na? So you just multiply and divide it by 2. So it will be 1 by 2 sin 2t, right?
सर
हाँ बोलो.
सर वो पहला वाला थोड़ा समझा देंगे, जो 2 कैसे है, 2 cos 2t, 2 पहले कैसे है?
Okay, Laplace inverse of 2s divided by a square plus 4 square. Now, Laplace inverse of what is the formula of means cos omega t?
सर s by s square plus omega square.
हाँ, so it is not exactly s by a square plus omega square, right? It is 2s by a square plus omega square.
Yes, sir.
So we can write that to here. Then it is s by a square plus 4 square. Sorry, not 4 square actually. It is
Sir, 2 square.
2 square. Okay, it is 2 square. Then it is exactly a formula. Do you get it?
Yes, sir. Yes, sir.
Look, always we can adjust a constant. So somehow if a constant, unnecessary constant is there, you can means bring it outside the operator. Okay. And if it needs, if some constant is needed, Then you can multiply and divide. In that way you can adjust it. ये एक लॉन्ग क्वेश्चन है, मतलब ये 5 मार्क्स का क्वेश्चन हो सकता है. Laplace inverse of 2s plus 1 divided by s plus 1 whole square plus 4. I have not concluded the problem yet. Okay. ft, is it clear now? देखो ft we are getting 2 cos 2t minus 1 by 2 sin 2t. देखो यहाँ पे 2 जरूरी था, ये 2 के लिए क्या किया मैंने, 2 1 by 2 कर दिया. ठीक है, अभी 1 by 2 that is outside the Laplace inverse. Now Laplace inverse of 2 by a square plus 2 square, that is sin 2t. That's it. That is why 1 by 2, that constant term is here. Clear or not?
Yes, sir.
Now we have a, we have small ft. Therefore Laplace inverse of f of s plus 1, it is what? E to the power at, means e to the power minus t into small ft. तो small ft अभी निकला है, वो small ft होगा. तो I am writing in the next page. Therefore Laplace inverse of 2s plus 1 e to the power at, a is minus 1, and small ft means 2 cos 2t sin 2t. This, that is our Laplace inverse of this function. Actually पहले और एक दो छोटा छोटा प्रॉब्लम्स करना चाहिए थे, देन ये वाला पूछते तो सही रहता. Okay, I am now asking those
Sir,
big part. Huh?
sir, from where does the e to the power minus t come from?
What is the formula of this s shifting? Laplace inverse
Okay,
of
okay.
f of s minus
E to power
a
t. Yes, sir.
is equal to e to the power at into ft. Okay,
Yes, sir.
and according to the problem, f of s minus a, it is our f of s plus 1, right?
Yes, sir.
It is our f of s plus 1. Therefore, a is what? A is minus
Minus
1.
1. Yes.
And small ft I have evaluated in that way. From f of s plus 1, you write fs. Then from that fs, you take Laplace inverse, you will get ft. Okay. I am showing some smaller version of this problem first. So you tell me Laplace inverse of 1 by s minus 1 whole cube. Or every time I am taking 1, say it is 5. Okay. How to find it? So Laplace inverse of, देखो 1 by, if it is Laplace inverse of 1 by s minus 5 only, I can write it immediately by the formula e to the power 5t. But it is not exactly that. So I can't apply any tabular formula. a tabulated formula. So you have to apply. It is of the form s minus a, na? So you can think it as here f of s minus 5. It is a function of s minus 5, na? I can think 1 by s minus 5 whole cube. So by the s shifting theorem, Laplace inverse of f of s minus a क्या हो जाएगा? E to the power at into ft. Now a is what?
5.
F of s minus a form. A is 5. Now we need ft. So e to the power 5t आएगा. That is confirmed. E to the power 5t into ft. What is ft? Ft is the Laplace inverse of fs. So what is capital Fs?
Sir, 1 by s cube.
1 by s cube. Correct. Then small ft. It is Laplace inverse of capital Fs. So Laplace inverse of 1 by s cube. Can you find such type of function 1 by s cube in the table?
Sir, 1 by 2t square.
देखो this one, right? 2 by s cube I have in the tabulated form. 2 by s cube. So you multiply it by 2 and divide it by 2. Okay. 2 into, sorry, 1 by 2 into 2 by s cube. Can I write this? Then that 1 by 2, you can bring it outside the Laplace inverse. Now it is a tabulated formula. It is t square. So t square by 2. Do you get it?
Yes, sir.
Yes. And finally you write. So Laplace inverse of 1 by s minus 5 whole cube. It is equals to what? E to the power at. So e to the power 5t and then t square by ft what? T square by 2. E to the power 80 into ft. So that is the chain. Okay. To apply s shifting, given f of s minus a. So from f of s minus a, you find what is fs. Then you take its Laplace transform to find ft. Then you write e to the power 80 ft. Fine. We can write one more line here. Laplace inverse. That is a problem type. Laplace inverse of f of s minus a. Now I am giving you another problem. Laplace inverse of 3s this. You do it. Okay. In the meantime, I'm taking attendance. So in between, you complete it. I'm giving you the simplest one. Okay. I'm giving you okay, 3s plus 3. This. No, sorry. 6. It will be more simple. I'm not taking attendance. You try it. I will ask at last. Have you written the problem?
Yes, sir.
Yes, sir.
Yes, sir.
Roll number 742,
Present, sir.
44,
Yes, sir.
45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48,
Sir, he's
48.
present. 48 present, sir. Chat box.
Okay, 49,
Present, sir.
51, 52,
Present, sir.
53,
Present, sir.
55,
Present, sir.
56,
Present, sir.
58,
Present, sir.
61,
Present, sir.
63, 64,
Present, sir.
65.
Sir, 763 written in the chat, sir.
Okay, 65,
Present, sir.
66,
Yes, sir.
67, 70,
Present, sir.
71,
Present, sir.
72,
Present, sir.
73,
Present, sir.
75,
Present, sir.
76,
Present, sir.
78,
Yes, sir.
79,
Present, sir.
80, 85,
Present, sir.
87,
Present, sir.
89,
Present, sir.
90,
Present, sir.
91,
Present, sir. Sir, roll number 67 has written in the chat box.
later, 92,
Present, sir.
97,
Present, sir.
98,
Present.
99, 801,
Present, sir.
2,
Present, sir.
4,
Present, sir.
6,
Present, sir.
8,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
14,
14 present, sir.
15,
Present, sir.
16,
Present, sir.
17,
Present, sir.
18,
Present, sir.
19,
Present, sir.
21, 22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25, 26,
Present, sir.
27,
Present, sir.
25 present, sir. 25,
Okay.
25.
28,
Present, sir.
29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32, 33,
Present, sir.
34, sorry, 35.
Sir, he left the university.
Okay, name is here. 36,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40,
Present, sir.
41,
Present, sir.
43,
Present, sir.
45, 46.
Present, sir.
So 8:45 present.
Okay. 48,
Present, sir.
49,
Present, sir.
51, 52,
Present, sir.
51 present. Okay, 53, 54, 54,
Present, sir.
55,
Present, sir.
57,
Present, sir.
59,
Present, sir.
60,
Present, sir.
61,
Present, sir.
63,
Present, sir.
64,
Present, sir.
67,
Present, sir.
68,
Present, sir.
69,
Present, sir.
70,
Present, sir.
71,
Present, sir.
72,
Present, sir.
75,
Present, sir.
76.
Present, sir.
Okay.
Sir, 751 present.
Sir, 799 present.
Sir, 767 also present.
Sir, 780 present.
हाँ 767 दिया है.
Sir, 780.
751, 751.
751. Okay.
Sir, 780.
799.
780.
Sir, 799.
799.
Thank you, sir.
हाँ 832. Oh,
Sir, 853 present.
8.
853.
तो जो एब्सेंट था सब फिल हो गया.
Sir, 854 को मार्क किया आपने.
हाँ 854 गिवन. ओके तो किए हो.
Sir, e to the power minus 2t 3 cos t.
e to the power minus 2t
3 cos t.
3 cos t. Okay, let me check.
Cos t divided by 3 नहीं होगा.
हाँ देखता हूँ. देखो जैम बोर्ड देखो. Laplace inverse of the denominator you have to write it in the whole square form. So 3s plus
Sir, you have
6.
not shared the screen.
Oh, it is. You can follow the jam board. Okay, you can. I'm sharing.
Okay, sir.
तो शेयरिंग ऑन है कि नहीं. नहीं है शायद. वो लैपटॉप बैटरी लो हो गया. S plus 2 whole square plus 1 right in the denominator. तो Laplace inverse of if we take 3 common, it will be s plus 2 divided by s plus 2 whole square plus 1. So 3 common, outside the Laplace inverse, s plus 2 divided by s plus 2 whole square plus 1. So it will be 3 into e to the power minus 2t and s by a square plus 1. That means cos t. So 3 e to the power minus 2t cos t. Okay. I have written in short.
Yes.
You just do it how I am writing. So for that you write f of s plus 2. What is f of s plus 2? Okay. f of s plus 2. You can take after 3 taking outside rest, that is f of s plus 2, not an issue. It is s plus 2 divided by s plus 2 whole square plus 1. So from here f of s will be what? S by a square plus 1. Then ft will be Laplace inverse of fs. So Laplace inverse of s by a square plus 1. Therefore it is cos t. Okay, that's how I am getting ft cos t. Now here a is what? A is minus 2. So e to the power at into ft, that is the form. So e to the power minus 2t into cos t. Okay, that's all for today. Still, if you have doubt on this problem, you can ask me in the next class. Thank you all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.